life.
I don't really know what else I got for you, so I guess we should just start rolling. Yeah. Uh-oh, you look mad. My fault. You got it?
I got it. That's the best part of my day.
I just
Math class is always the best part of your day.
but I couldn't see much, so
It was in physics.
She's like, what? Oh yeah, it is.
It is actually the best part of my day.
But she was about to say, she was like, oh wait.
this is the wrong number.
I will tell you, by the way, that one of the many things that I am thankful for is that I have you guys 7th hour every day. Because when I leave here, I have left school after 7th hour classes that I was angry, like all the time. And to end the day and go, you know, even if we have a bad day in class, my bad day here is like a great day in other classes. So, yeah, I was thinking about that last week or so, a week or two ago. And for those that are watching that are in 1st or 2nd hour, I'm thankful for you guys too. But yeah, it changes your entire world. For me, it changes my entire world ending the day on a good note. So, thank you.
You're welcome.
Homework questions. Wasn't bad? That's the way it has been all day today. So, yeah, you'll notice that I'm not saying, really? I'm just waiting, and if anybody has a question, that's fine. But, yeah, 1st hour had no questions, 2nd hour had 1. And that took like 12 seconds to do, so. Nothing? And my sense was that the majority of people had done it, and it was easy, rather than other days when I say, there are no questions because nobody did it. And I'm not sensing that today. So we'll move on then? Yeah. What do you think we should work on today?
Hyperbolas.
Hyperbolas. Wow. Okay, let's do that. I was going to give you a day off, but if you want to do hyperbolas,
Whoa, go back.
I was not giving a day off. You know that. You know that. As you can tell from the board, today was not a day off. And I'm also thankful that Ms. Carroll did not erase all the stuff that I wrote earlier, so it makes my life easier. I don't care, it's too late, we already started. What?
It was,
Oh my. He was gonna start the notes.
It would make me feel good.
I know, especially from his.
That's what I mean, yeah.
Everybody dancing in the moonlight.
I get it.
Have you ever heard the song King for a Day?
I've heard of it. I haven't listened to it.
It's in my head, and it's not stopping.
The main is non-stop.
Just bear with me.
I dropped it. Grab it.
I can't.
How do you turn it on? Oh, 21st? Okay.
It's too hard.
Okay, hyperbolas, where should we start? Definition, that's a great idea. Let me think about the definition of a hyperbola.
Is it that?
It's a high parabola.
It's a
Parabola.
hyperbola.
It's a hyperbola.
It's a hyperbola.
Yes.
Anybody want to throw out a suggestion for the definition of a hyperbola?
The actual
Okay,
one.
go ahead.
Is it a set of all points such that the difference of the distances to two fixed points foci is constant?
Wow. That's just right off the top of your head. That's
Yeah,
fantastic.
genius.
You got it. Hyperbola, the set of all points such that the difference of the distances to two fixed points is constant. Does that sound familiar?
Kind of.
Yeah.
I hope it sounds familiar.
Parabola?
What does it sound like?
A circle?
Does it sound like an ellipse? So, what was ellipse?
Set of all points. Wait, it's the same.
It was exactly the same thing?
No, it wasn't.
Yeah.
That was the sum of gamma stop.
It should have been exactly the same thing, except that instead of difference for hyperbola, it was sum with ellipse. Same thing. Which goes back to what we talked about at the beginning. The good news is that there are a lot of similarities between the conic sections. And the bad news is there are a lot of similarities, but not exactly the same between the conic sections. So that's why, a lot of what we talked about is ways to keep them separate. So anyway, there it is. The only difference is the difference. Okay. Would you expect one formula or two formulas?
Two.
Two. One for
Vertical.
vertical and one for horizontal. So, here they be.
Here's
X minus h squared over a squared minus y minus k squared over b squared equals 1. That sounds familiar.
It's just like, so it's just subtracted.
It's the negative.
It sounds like an ellipse, but
Subtract.
Minus.
it's a minus between them instead of a plus. Oh, that kind of sounds like that, doesn't it? Yeah. Okay. So this is exactly the same formula as the first ellipse formula. The only difference is that instead of a plus in ellipse, we have a minus in hyperbola. Second one's a little bit different, and it's because of the sign stuff. We could have written the ellipse one basically the same way, but they always write the x first in the ellipse. But the second one is y minus k squared over a squared minus x minus h squared over b squared equals 1. So once again, the good news is that with a hyperbola and an ellipse, we have a lot of similarities. And it's also the bad news, yeah. C. C is the distance from the center to each focus. Did we do that before?
Mm-hmm.
For what? Ellipse. It's exactly the same thing as an ellipse in that regard. What about A? The distance from the center to each vertex.
Yeah, that's the same.
That's the same also. Cool. We'll get to this in a minute. Hang on with that. There was a B. There it is. I see it. And in an ellipse, it was a squared minus b squared equals c squared. But in a hyperbola, right? Remember what we said the other day? Change the sign. It's the opposite of this sign to the two denominators to get c squared. So here it's a squared plus b squared equals c squared. That's what we wrote up there. I like thinking of it that way because then I don't have to think, all right, if it's a hyperbola, is it plus a squared plus b squared or a squared minus b squared? Because those are the types of things that I'm going to forget. So my way of remembering is it's the opposite of that. Okay. Red. Money red. All right. Perhaps the biggest difference between an ellipse and a hyperbola is the way that it looks. In other words, the way that we have to graph it. So usually I would go into a couple of other things here, but for this one, we're going to jump right into a graphing problem. We're going to take a look at question number 30. Y plus 1 squared over 36 minus x plus 2 squared over 9 equals 1. question number 30. Your homework goes to 31. So we're kind of jumping right into it. We want to graph this thing. Oh, I'm sorry, before I get there. What do we typically, what's another big important thing that we want to know about all these conic sections? Center, which we kind of know. What else?
Axis.
Whether it's vertical or horizontal, right? That's been big for us. How did we tell in a parabola, vertical or horizontal? The unsquared term told us. In an ellipse, how did we decide? Bigger denominator. Good. In a hyperbola, nope, the positive term. Whichever one is positive, that's the direction it's going to go. In our first formula here, is x or y positive?
X.
Or are they both positive? Because that minus goes with the y, so y is negative, x is positive. So since x is the positive term, it's going to be horizontal. Here, y is the positive term, it's going to be vertical. Make sense? What do you think the center is, typically?
-2.
No, I'm saying typically in like over here. HK, yeah. So what's the center of this one? Center is -2, -1. Okay. Is it horizontal or vertical?
Vertical.
Why do you say it's vertical?
The Y
The y comes first. Yeah. Not because the y has the bigger denominator. And we're going to see a couple in your homework and stuff like that where the bigger denominator doesn't, it actually goes the other way. And in fact, in a hyperbola, they could have the same denominator. In an ellipse, if they had the same denominator,
Life would be hard.
it would be a circle. So it wouldn't even really be an ellipse. So we can't have that happen in an ellipse. But in a hyperbola, since they're opposite signs, they could have the same denominator. So that's why positive term tells us. Center is -2, -1. You said it was what? Which way? Vertical. Vertical. Okay. Do you know anything else?
A equals 6.
A is 6.
B is 3.
B is 3? Is that what you said?
Yes.
Okay. What about C? Oh.
36. 25.
Radical
5. C is 5.
Yeah.
45, not 25.
36 plus 9 gives us 45.
I did mine.
So square root of 45 or 3 root of 5. Okay there? Questions so far? All right. When we draw the graph of a hyperbola, it is going to take a lot more room than any of the other conic sections. I know, isn't that exciting? So when I'm going to draw the graph of the hyperbola, wow, that's even a terrible axis.
I have 7 problems for homework on Monday. This one.
Is it bigger, or is it just bigger?
Maybe
Like, is it 2 times as big or like 3 times as big or just like?
I don't think it'll be 3 times as big, but I'm going to go up to, I'll probably go up to somewhere between 10 and 15 on my axis. That's basically what I'm talking
Maybe because
about.
it's harder.
Wow, terrible. Thinking about what I'm saying here. Okay, to start with, in terms of the graphing, we're going to start it exactly the same way we do with an ellipse. So, bless you. So if this were an ellipse, tell me what we would do.
Center -2,
Center.
-1.
-2, -1, -2, -1. There we go. Okay, then what would we do? We would go
Distal, right? The distance
Up
from the
6,
bridge.
up and down 6.
So up 6 and down 6.
good. 6 units
Up.
in the y direction. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And then we would
Do 3 units in the x direction.
3 units in the x direction. So 1, 2, 3. 1, 2, 3. And in an ellipse, what would we do now? We'd connect the dots and be done. In a hyperbola,
It's a
we're just getting started. Each hyperbola will take about 20 to 25 minutes to graph. No, I'm just kidding.
You had me right here.
But it is going to take longer, and there is definitely more to it. It's not 20 minutes long, I promise.
I was
So,
afraid.
here's what we're going to do.
Mini panic.
Okay? Once again, in an ellipse, we just collect
Collect the dots.
Connect the dots, and we'd be done. In a hyperbola, what we have to do is we have to draw a box. And the box is going to be horizontal and vertical lines. It's going to be a rectangle, unless A and B are the same, in which case it's going to be a square. But it's going to be a rectangle, and we're going to use all of these points, but they have to be horizontals and verticals. One of the mistakes that people make is they start connecting the dots like a diamond, and that's not a box. So we have to go horizontally over, and you want this to be as accurate as you can.
Good.
And we've drawn our box. Okie dokie? Man. No rocket science here, right? We just drew a box. Okay. And now, let's see what this one looks like. We're going to draw the diagonals of the box and extend them. And we're going to do this with dotted lines. So what I typically do is I go to one corner, and then I go through the center and out the other corner. That gives me the most accurate. That's one. Draw.
Whoa. I cannot do this in a rectangle box.
Has to go through the center. Will diagonals of a rectangle go through the center?
Yes.
Yes. So they have to go through the center. So this is interesting. Oh, dotted lines. I've seen dotted lines before.
Oh,
Asymptotes.
No.
Would that be fun if we had asymptotes in conic sections and everything? That'd be so cool.
That'd be so fun.
Well, we do. These are
I'm
asymptotes.
crying with joy.
The good news is that we are now about 95% of the way done. Although we have not yet drawn any part, almost any part of the
Too
hyperbola.
much panic, not
Yes,
enough disco.
So are the dots, are the points that we drew?
Sad
That's what I'm
truth.
about to touch on. Give me just a second. Okay. So now, you'll notice that since we started drawing this, we have not in any way, shape, or form mentioned that.
Vertical.
That it's vertical. We have not mentioned that it's vertical, correct? We just drew our box, we drew our asymptotes. Now we have to pay attention to which way it goes. Does it go vertically or horizontally? In this case, as we said, it goes vertically. So that means that from the center, we're going to move vertically. We're going to go vertically to the points on the box. In other words, this point right here and this point right here. Those 2 points are our vertices. If the hyperbola was horizontal, we would have gone horizontally and gone to this point and this point. With me there?
Mhm.
But everything up until then, we would have done exactly the same way.
Is it always going to be the points that we already have?
It will always be the points we already have. It'll either be the up and down points if it's vertical, or the side-to-side points if it's horizontal. And now, these are our vertices. So all we're going to do from here is draw towards the asymptotes, which we're used to doing. So, we start here and we draw towards the asymptote. We start here and we draw towards the asymptote. We start here and we draw towards the asymptote. And we start here and we draw towards the asymptote. And the purple is the hyperbola.
So this is just that, or
Did I answer your question?
Okay, yeah, because I was going to ask if the outside points were
Yeah, that's what I was thinking. I was going to answer it, so that.
wow.
Okay. Questions on the graphing? I can't answer that. You will be asked a couple of questions, perhaps, about the asymptotes. Okay? One of the questions you'll be asked, because the asymptotes are lines, you might be asked the slopes of the asymptotes. Now, the slopes of the asymptotes, most books will tell you that the slopes of the asymptotes are either plus or minus A over B, or plus or minus B over A. And it's one of them if it's horizontal, and it's the other one if it's vertical. How do you feel about that?
Okay.
Why don't you like it? Too many options. Too many options. I don't like options. There's too much to remember in conic sections to say in this one, well, if it's vertical, we're going to do this, and if it's horizontal, we're going to do this. So I try to find ways to make it easier for me to remember, because I'm not a good memorization person. And so here's what works for me. What works for me is it's either going to be A over B or B over A, but it depends on whichever one is under Y is going to be in our numerator. So for instance, in this one, okay, here's Y, B is underneath it, so it's going to be B over A. This one, here's Y, so it's going to be A over B. Does that make any sense? So that's where this comes in. Okay? For me, this is the way I remember it. The slopes of the asymptotes are plus or minus, and I have to write the square root because it, this is A squared and B squared. So the square root of the denominator of Y over the denominator of X. Right? But it's always Y over X. And for me, that makes it easier to remember. Now I don't have to worry about, is it vertical? If it's vertical, it's going to be A over B, and if it's horizontal, it's going to be B over A. No, not my style. So that works for me. Yes, sir?
So, like, how do you come up with stuff? Like, is this
I have to find a trick to remember things. Like I said, I'm not a good memorization person.
You're rich.
No. It's my laziness, to be honest. I don't want to have to remember more stuff. So find a way to make it work with something easier. So, are we okay with that?
Yeah.
Now, therefore, in this problem right here, what are the slopes of our asymptotes?
Plus or minus 6 over 9. Or 6
Plus
over
or
3.
minus
6 over 3.
6, denominator of Y, over denominator of X. So 6 over 3, which is?
2.
No. Plus or minus 2.
It's plus or minus because
It's plus or minus because if you look at the two lines here, one of them has a slope that is positive, and the other one has a slope that is negative, but the slopes are basically the same, they're just opposites. Okay, so the slope of this one would be 2, and the slope of this one would be negative 2. Last thing on the asymptote stuff. Eventually they're going to ask us not just for the slopes of the asymptotes, but for the equation of the asymptotes. And this really complicates things. Okay? What do we need to get the equation of a line?
The slope and the line.
The slope and a point, right? They both go through there, right? They both go through the center. So if we have the slope and a point, what form could we possibly write the equation of our line in? Point slope form. And the good news is that I know everybody remembers point slope form, so we're good there. I learned that first hour. So you are going to want to remember point slope form.
We put that on our formula sheet.
It's a formula, right?
Yes.
Anybody remember anything about point slope form?
Y
Minus
Y1
Y1, really good.
equals N X minus X1.
Yes.
I don't know.
That's awesome. Good
I
job.
get like a candy bar.
A mental candy bar.
A mental candy bar.
You can have more turkey tomorrow. Do you have turkey tomorrow? All right, so, no, stay with me here, okay? I don't have much time. Okay, so, let's do it for this one. Y plus 1 equals plus or minus 2, and we can just leave it as plus or minus 2, that's fine, times x plus 2. And that is the equation of the asymptotes. And you can leave them like that. Huh. That's interesting. Look at this. Does it make sense? So we don't really have to, well, we got to remember what it's basically going to look like. But the y plus 1, the x plus 2, the slope goes right there. Okie dokie? Questions? All right. Let's start looking at the homework problems that you're going to get.
Ow.
Ow.
Yes, ow.
Mom, that is painful for you to turn it out. All right. Does anybody still need the graph?
Wait, what did I do?
No?
How did I spin it though? Now I'm wondering what it's been on this whole
Probably
time.
like slit it.
Because that'd be bad if it's just been filming you and Sophia the whole time.
Okay, so we are going to take a look. We're going to look at question number 2. I didn't hear you. What did you say? This is Diet Pepsi. It's not always that.
Mine's worse for you than rings.
Oh. Thanks, that makes me feel better about myself.
Just so you know.
Number 2. Tell me what you know. Center is 0, 0, I would agree. Next thing you know. Vertical. It is vertical because?
Y is positive.
Y is positive. What else do we know?
A is 6, B is 4.
A is 6, B is 4. Since A is 6, that means that
Distance from the center to the vertex is
the
6.
center to the vertex is 6 units.
6 units up.
Okay, so you already told me it was vertical. As soon as you told me it was vertical, what could you eliminate? B and D. Because these both open left and right. They both open horizontally. So it's either going to be A or C. Is that fair?
I'm going to say it's going to be C.
It's A.
Since A is 6, then that means that from the center
You go 6.
to the vertex, and remember it starts to be drawn from the vertex, it's going to be 6 units.
C doesn't even have
So
a 6.
this is 10, so each one is 2, so 2, 4, 6. 2, 4, 6. Whereas this one, well, it only goes up to 2 here, so it would be 2, 4, so it should be drawn from here. Therefore, our answer is
A.
A.
It isn't about that, but is the one that you move in the direction, or is the points that you make in the direction that are the graph, are those the foci?
No. No, I'm going to talk about foci in a minute, but that's, I'm glad you brought that up. Well, actually, I'll talk about it a little bit now. The foci, remember where they were in a parabola? Or where it was in a parabola? It was inside the curve of the parabola. Well, it's going to be in the same general neighborhood for each part of this. So in this one, for instance, the foci might be around in there. Okay? For this one, the foci might be around in there.
How do foci still always?
How do we know? Good question.
They
How do
give
we
it to
know?
Well,
I know, wasn't it great? You asked a question, I just asked it right back to you.
Is there a formula?
Is there a formula to find the foci?
A, if you find a distance from the center, you'll find the A squared.
Wait. What tells us how
yeah.
far it is to the foci?
C.
C, right? C is the distance from the center to each focus.
Oh.
So in this case,
Oh, 6 plus 4. Oh, wait, 36.
52. C is the square root of 52.
The square root of
Yes?
52.
The square root of 52 is
About 7 point.
a little more than 7? Probably lower, but I would guess in the 7.2, 7.3 range. But anyway, whatever. So therefore, from the center to a focus is 7.2 or something like that. So 2, 4, 6, 7, so somewhere in there. Somewhere in there. And that's where the foci would be. Doesn't matter what? Yes. Especially when you're asked in the question, what are the foci? It becomes particularly important then. In terms of these, no. All right, I got to roll. I got to keep going. Let's take a look at number 26. There are a lot of dots.
And then you put in the center for the point.
26, tell me what you know about 26. The center is -3, 2. Okay.
It's a horizontal graph.
A is
Horizontal.
Horizontal.
Yeah.
But